Hello everyone, welcome to Data Science Community. In today's lecture, we are going to learn how we can predict a car price using machine learning model. So without wasting our time, let's start and let's go to our Jupyter Notebook. Okay. So this is our notebook. I will provide the link of this notebook and dataset in our description. You can go and download from there. Okay. And so in our first cell, as always, we are first installing or importing all our libraries. Okay, so here we are importing our dataset by using this read_csv function. If you do not watch my video on pandas function, which we use in machine learning and data science projects, you can go and check it out, that video first. The link is in description. I already explained all the data exploration or data pre-processing process in that video. Okay, whatever function we need to learn, so you can go and check it out from there. Okay, and here in this cell I am using isNull function to check the null values present in my data set, and here I am using duplicated functions to find the duplicate value present in my data set. Okay, now in this cell here you can see that I am dropping the column car ID because we do not need that column. Okay, you can see here this car ID column, here simply the numbering is there. Okay, so we don't need that, so that's why I am dropping this column. And here we use x1 for column, and if you write x0 then it is for row. Okay, and df.head function to read the first 5 rows of our data set. Okay, and here I am showing the statistics of my data set. If you write include all, okay, then here you can see that all the values of categorical variables. Okay, so in our data set here we have categorical variables, and these were the numerical columns. Okay, so if I write include all, so it will write the statistics for the categorical columns also, or if we remove this include all from here, then it will only return the descriptive statistics for numerical columns. And here it will return the count, mean, standard deviation, minimum, maximum value of each and every column present in our data set. Okay, so in next cell here you can see that I am separating the numerical categorical column here. Okay, so here you can see that I am selecting by using the data type, where the data type equals to object. I am storing those columns into this df_cat instance. Okay, and here I am applying loop on df_cat dot columns and finding the unique value present in our column. Okay, so for finding unique value you can use any unique function. So here I am returning the column name and the unique value present in that particular column. Okay, so here you can see the name of the columns and number of category present in each column. Okay, now for converting this categorical columns into a numerical value, because our machine learning model need a numerical values for performing machine learning. Okay, for applying machine learning model. Okay, so here I am converting the categorical column into numerical by using label encoder. Okay, here you need to use this sklearn.preprocessing package, and here you need to import label encoder. Okay, then you create an instance of that. After that you need to write label encoder.fit transform, and here you need to provide the column name. Okay, so that's how you can change the value of each and every categorical column. Okay, this was the one way of for label encoding. Okay, there is many other ways you can encode your categorical columns into numerical columns. Okay, now here you need to declare feature vector and target. Okay, so here I am assigning my x and y values. Here y is our target variable, or we can also say it is also known as dependent variable, and here x is our independent variable. Okay, by using this x we can find our output, which is our target variable. Okay, and here I am storing, except my target variable which is price, I am storing all the data set in this particular x. Okay, and in y I am storing only the price of the cars. Okay, now here we are scaling our model. Okay, so that our model will get better accuracy. For that we are using standard scaler. Okay, so by using standard scaler, in our numerical columns, it will standardize our values, okay, present in our columns. Okay, so here I am using standard scaler. Sorry, I did forget to run this cell. Okay, Now here I'm importing train test split, okay, to split my data into test set and training set. Here I'm using train test to split. Okay, here you need to provide the value of x and y. Okay, here is our x and here this is our y. Okay, and this was the test size. Okay, now here I'm importing my linear regression model. Okay, and in here this was our model. This is the stance of our model. Here we use fit method to train our model. Okay, and for training purpose we provide the x train and y train value. This was the target required output value, and this was the input. Okay, and here we have our predicted value for x train. Okay, and for y-x test we are having this. For predict the outcome we use predict function. Okay, and here you need to provide your data set or for which you need to predict a value. Okay, so you need to mention here, and this was the predicted value for x test. This is the predicted value for x train. Okay, and for checking the accuracy of our model we use R2 score in linear regression. Okay, so here you can see that 88% accuracy. Okay, here we are getting the 88% accuracy, and here we are using the R2 underscore score, and here we need to provide the expected output, and this was our predicted value. Okay, so here is our accuracy of our model. Okay, so that's all for this video. That's how you can apply multiple linear regression on any data set. Okay, thanks for watching. Like, share and subscribe for more such videos.